And we're going to start with just the first section, so 1 through 5. Which of those do we want to see? Do you go over, have questions about?
We just, well, I guess 1, 3, and how about 4?
You said 1, 3, and 4. If we have other questions about the others, we'll go back to this. So with this, we are on direct variation. In order for it to be direct, it needs to look like this format: y equals kx, similar to your slope-intercept form, but your b is always 0. So of these 6, this would not match that because we're dividing instead of multiplying the x. This one would also not match that because we have a b value that's not 0. This would match because we do have a y-intercept, but it's 0, so it's okay. This one would not because of that same thing. The b value is not 0. The others can be rewritten as y equals 2 over 3x or y equals 1 over 2x. Both where your b values are 0, so those would both be 0. Questions on 1? We have different variables, but same process. They tell us A varies directly as B. So this would be like our Y, this would be like our X. Whatever comes first is always like your Y, it always equals. We have to find the missing value. So we have to find our K value before anything. And in order to do that, we're going to use K equals Y over X. If, while you're doing that, you forget how to find that, you can look at the original. Divide by x, solve for k. And that would give you this equation. K equals y over x. And then we can use the two numbers they give us to find k. A is like y and b is like x. This would be k equals 8 over negative 3. That would be as simplified as possible. Then we would need to find the b value when a is negative 16. So if we rewrote this into the equation, instead of y equals kx, it would be a equals bx. But now we know what a is, and now we know what, I'm sorry, that was wrong. I didn't mean to put x. I meant to put b instead of x and then k instead of k. Now that we know what our a value is, we can put that in. We also know our k value, and we can solve for b.
Wait, what happened? Oh, no, never mind.
That was for somebody else. So to solve for b, because we have a fraction, we can take it, flip it, multiply on both sides. Yes. Positive 48 over 8 is 6. And that would be the final answer for that. Do we have questions on that before we do 4? Four is really the same thing, but different variables and there's more words. The number of gallons G varies directly, so this would be like your Y, with the number of miles MU, so that would be like your X. So the trick strip of 215 miles, that's your M or your X, requires 9 gallons, G or Y. So before we focus on the rest of the sentence, let's just use those two numbers and find our K value. So it's going to be K equals G over M or Y over X, so 9 over 215. Let's see if that's a nice decimal or not. I'm going to leave it as a fraction. Of 315. I don't know if that's what you need to do. What were you about to ask?
I was gonna say can you simplify it, but I put 15 instead of 315.
Okay, so we have our K value. Now we're looking for how many gallons, G or Y.
Wait, can you simplify it to 135?
That's possible. I didn't put it in as an actual fraction. 315. Yes. So we're looking for G or Y. We have M or X. So we're going to put in those values and solve for G or Y. G equals 1 over 35 times 200.
Uh, 40 over 7.
I think that's right. I don't remember that answer.
Because you were looking for a real world problem, how many gallons, you would put 40 over 7 gallons, you would put it as the decimal. And gallons are usually in 0.2, so 2 decimal places, so 5.71 gallons. Make sure you're putting the label since it is real world. Questions on that one? The second objective starts with 6. Do you have questions about 6 or want to see 6?
Is it different from the top?
Slightly because of the equation. So we're looking for equations that look like this, where we're dividing x. This one we're not dividing x, so that's not one. Here we are, so the 4 divided by 3x is 1. This one, if we were to solve this for k, we would be multiplying both sides by x. So those formats are the same, so that is here we're dividing by x, so that is also 1. This looks more direct, so that is not 1. And so does this one. Questions on that before we go to the next page? And then 7 through 11, questions there.
How about 8 and 10?
We'll start with those. If we have any others, we'll go back to those. I'm going to rewrite the equations at the top. Y equals k over x, and k equals y times x, x times y, doesn't matter. And then for 8, we have x and we have y. We need to find k. So multiply those two together. It wouldn't be a nice decimal, so I'm going to leave it as a fraction, 13 over 3. Then if we were to put that into our equation, we're looking for x and we have y. So 1.9 equals 13 over 3 over x. Doesn't look nice in that format. So to get rid of the fraction within a fraction, we're going to take the x multiplied by the reciprocal to the denominator and numerator of that entire fraction.
How would you do this on the calculator?
This part you wouldn't, but the next part you'll be able to. So that entire denominator cancels, and now we have 1.9 equals 13 over 3x. Now it's a little bit better to solve. Because now, if we're solving for x, we can multiply both sides by 3x.
5.7.
X equals 13. And then divide both sides by 5.7.
Uh, 4.3846.
Yeah, there's some decimal. So you can do like 2 decimal places. Questions on that one before we do 10? For 10, we have the volume V varies inversely as the pressure P. So V is going to be like our Y, P is going to be like our X. P or X is 20. And the volume or Y is 13. So we're going to multiply those two together to find K. Would be our K value. Then we are given, we're looking for the volume, so we're looking for V or Y when the pressure is 10. So we would set up our equation. V equals 260 over our P or our X, which is 10. What would V equal?
26.
26, and there's a word problem, so whatever the units were, cubic feet. Questions on that one or other questions in this section? Twelve through 19. What questions do we have there?
19. How about 13?
setting up the equation. So if b varies inversely, whatever comes first is always going to be equal. So b equals, there's always going to be some k value in there. So b equals k. Varies inversely, then we're dividing by whatever comes next. So dividing by k, or dividing by f, sorry. K is divided by f. And then directly is multiplying. So we can either put s next to it, or we can put s next to the k in the numerator. Either or. With 16, we would have to set up the equation first and then solve it. Varies jointly is the same thing as directly multiplying. There are just multiple variables. So x varies, so it's going to be x equals k. And then varies jointly as y and z would be y times z. Then we would start to put the numbers in. We have x, we have y, we have z. Put all of those in. 20 equals, we don't know k, but we know y is 2 and z is 5. And then we're going to solve this for k. Multiply this with 5. And divide. Once you have your k value, you're going to take the remaining numbers and solve. So we know x is now 16. Our k value is 2. Our y value is also 2. And we don't know z.
Wait, isn't z 5?
Was. Now it's not. Now we don't know what it is. So we can start solving for z, multiply, and then divide. Questions so far? 19, we have to read it, figure out what type, how we're going to set it up, and then start to solve it. The cost C vary jointly, so the setup is going to be similar to 16. C equals K times the width and the length, so we're going to call that W and L. We know the debt cost $14.40. Don't know K. You know the width is 12. The length is 20. So we can use this information to find K, multiply, and divide. When you divide, what would you get for K? So then we're going to use that value in our original equation with the new numbers given. Now we are looking for the cost, so we don't know C. Our K value is 6. Our width is now 107, and our length is now 4. Multiply all of those together.
2,568. So combine.
Was there a decimal?
On.
Other questions in this section or on this page? Go on to the next. Now we're in factoring by GCF. Which of these do we want to see if you go over and have questions about? 37. We'll start with that one. Right, so the goal here is to find something that we can divide everything by. If you're not sure about the factors, you can list them out. Some may be easier than others to see. I'm just going to list them as positive numbers and then we'll find negative numbers. If you know off the top of your head, then that's also fine. The factors of 80, 1 and 80, 2 and 40. I don't think 3 is 1. I have 4 is 1. 4 and 20, 5 and 16, question mark? 16. 8 and 7. And then 70, we have 1 and 70, 2 and 35. Don't think 3 is often. 4, 5 and 14. Oh yeah, 7. And then 90. 1 and 90, 2 and 45, 3 and 30. Not 4. 5 and 18. 6 and not 6. 15. And 91. So if you don't know the factors, you would need to do something like this. List all the factors of every single number and find the highest, which is 10. In this case, we're going to divide out a negative 10, since the first term is negative. And then if they each had the same variable, you would look at the lowest exponent. But in this case, the 90 doesn't have a variable, so no variables at all. Divide that from each term and see what's up. And we are only looking for GCF, so nothing else here. Do you have questions on that or other questions on this page? Move on to the next, if no other questions. Questions on this page?
Here's 52.
So with these, look for GCF in everything first. Is there something that we can divide each of these by? And I would say focus on the 18 or the 24. They have less factors than the 90 and the 120. So no, 18 can be divided by 1, by 2, by 3, 6, 9, 18. So like 2 would work. Is there something higher? 9.
6.
6. Divide everything by 6. What's 90 divided by 6?
15.
15 xu, 120 divided by 6, xb, 3yu, and 4y. Now the numbers are smaller, a little bit easier to work with. Then split the middle. And you're looking for the GCF of the first two. What do those have in common? 5 and
X.
x. Yes, one of these variables looks like the other. Take out 5 and x, divide that from both of them, see what's left. Separate. So 3u minus 4b. And then see what the last two have in common.
Plus 2u.
Not the u.
I mean y.
And then a number, just 1 or negative 1 in this case, so negative y, which would change the signs. Not y. And then you want your inside things to be the same. If they're not, then something's wrong. Keep bringing down that GCF from the outside. And then the outside things go together in a set of parentheses. And bring down one of the inside things. Other questions on this page? Yes. Same as the other one, look and see, is there something we can divide out of everything?
No.
Nothing of everything, something of maybe the first two or the last two. So then split it down the middle, find the GCF of the first two.
Would it be 5x squared or
Yes,
5?
5x squared. So look, they both have x's, and then look at the lowest exponent. And then when we divide that, what's left?
X plus 4.
And then what do these last two have in common?
Negative 1.
Which would change the signs to x plus 4. So then our factors would be 5x squared minus 1 and x plus 4.
Yes. Other questions on this page? Megida.
Because we're dividing by a negative. Okay, go on to the next page. Difference of squares now. Which of those do we want to see, do go over, have questions about? This one? So the goal of these look and see is, are the two numbers perfect squares? Is something times something equal 4? The same something. Same thing for 9. Same thing for the variable. And then are you subtracting? And if all of those are true, then you can move forward. You may have to look for a GCF. This one doesn't have one. So then what times what will give us 4?
2 times 2.
And what times what will give us n squared?
N.
So that would be first in your two factors. And then what times what will give us 9?
3.
3 and 3. And then put a plus in one factor and a minus in the other. And then that's it. 25. This does not have a GCF, so we can make our two factors. What times what will give us 25?
5.
What times what will give us x squared?
X.
Is x. And then what times what will give us 16?
4.
And what times what will give us y squared?
Y.
Plus and minus. Any others on this page? Go up to the text.
Eva.
These are all perfect squares. The only thing that's different between these is the exponent is different. It's no longer 2. As long as it's even, just cut it in half. Divide it by 2. This would be 2a squared plus 5 and 2a squared minus 5. And then 163 is the same. These are perfect squares. Your exponent is even. So divide it by 2. So 5b cubed plus 1 and 5b cubed minus 1. Now go on to the next page. Factoring trinomials when a equals 1. Which of those do you want to see, do, go over, have questions about? Eva? So we'll start with those. Looking for two numbers that multiply to be negative 30. That also add or subtract to be positive 7. So think about your factors of 30. I'll list them for this one.
Yeah,
3 times would work. One of them would have to be negative. Which one would work?
Negative 3 positive 10.
Correct. So then you're going to write this into two factors. Whatever the variable is, put that first in both. And then the two numbers you just found, put one in one and the other in the other. We didn't do this for this one, but it didn't also need it. Look for a GCF, if possible. But this one didn't have one. Questions on that? And then for 172, does that have a GCF?
3.
Usually it's whatever is first, it is going to be GCF. Divide everything by 3. A squared minus 9k plus 20. Then the rules are the same. You're looking for two numbers that multiply to be 20, that add or subtract to be negative 9.
Negative 4, negative 5.
Yeah. So if it's multiplying to be a positive number, there are only two ways to get there. They both have to be negative or they both have to be positive. bringing down the GCF, make your two factors, and then put the variable and the numbers. Other questions on this page? Does that one have a DCF 174? You have x squared plus 12x plus whatever you let us.
32.
So then we're looking for two numbers that multiply to be 32 and add to be 12. So two numbers from here. You're close. 4, not 9, but
8.
so x plus 4, x plus 8. On to the next page. Then the last piece of factoring, your trinomials when a does not equal 1 or is greater than 1. Which of those do we want to see? Do you go over have questions about? You go. 77 and 82. Always look for a GCF first, because the numbers could be really big. If you don't, I want to say it's 3, but I have to double check it. Yeah. So 3 can go into each of these, leaving us with 7n squared plus 48n minus 7. Then we are going to multiply 7 and negative 7. And we're looking for two numbers that multiply to be negative 49, but add to be positive 48.
49 and negative 1.
Yes. So then we would rewrite this into 4 terms. Keep bringing down the GCF. First and last stay the same. The middle becomes the two numbers you just found. Make sure you have the variable also. Then it becomes grouping because we have 4 terms. Split it down the middle. Keep bringing down that original GCF. Find the GCF of the first two. 7 and n, they both have n, both of those things. Which will leave us with n plus 7. And then find the GCF of the last two. 1, but negative. And then rewrite it. Bring down the original GCF. Outside numbers, 7n minus 1. Inside numbers, n plus 1. Questions on that one before we do the next one? Again, look and see if there's a GCF for all of them.
5.
We have 10p squared minus 27p plus 5. Then multiply 10 and 5. We're looking for two numbers that multiply to be 50, but add or subtract to be negative 27.
Negative 2, negative 25.
Okay, so rewrite this into your four terms. Keep bringing down the GCF. 10p squared minus 25p minus 2p plus 5. Split it down the middle. Look for the GCF of the first two. What would that be? 5p. Divide that from those two, leaving us with 2p minus 5. Find the GCF of the last two. But negative. We could change the signs. And then rewrite everything. 5 times 5p minus 1, 2p minus 1. Questions on that one before we move on? Once you finish writing that down, go on to the next page. Now in Unit 7, quadratics, first objective is solving quadratics by square roots. Which of those do we want to see? Do we go over, have questions about?
Uh, 189.
Any others? For all of these, you are trying to get the variable by itself. Let's see. So divide both sides by negative 9. Let's see.
66.
Whoever's music that is equal to 1. Thank you. Then to get n by itself, take the square root of both sides. If you take the square root and you get a whole number, then we can write it as the positive and negative version. But 66 is not a perfect square. So we would just write it as plus or minus the square root of 66. Or you can write it as the decimal. Find that decimal, type in second x squared, 66, and put in like 3 decimal places, 0.124. And you're writing this as a solution set. So either like this and just put the curly brackets around it, or you can separate them. square root, separated or together. Other questions on this page? If you were solving this and got a negative on the other side, that would then be no solution. We can't take the square root of a negative number. Go on to the next page if we don't have other questions on this one. And if you don't have your calculator, you'll need it for this. Which of these do we want to see, do, go over, have questions about? 96. What were you going to say? Okay. So for this, we're going to type this equation into y equals on your calculator. So y equals negative 2x squared plus 8x minus 6. Make sure you're getting negative, not minus, 2x then squared plus 8x minus 6. And then make sure you're hitting minus and not negative for the 6. Then you're going to go into the table, second graph, and you're looking for where your y values repeat. Here I see them repeating, and find the middle. So 2, 2, plot that point. And then you're going to plot at least 5 points. So go out from there, 1, 0, 3, 0. 0, negative 6, 4, negative 6. And once you have all of your points, draw a U shape through it. Draw arrows at the end. These also ask us to state the solutions. So the solutions are where it crosses the x-axis. Write those as ordered pairs. So 1, 0, and 1, 0. Are there any others on this page we want to see, do, go over, have questions about?
On the graph, like you said that we have to choose out of the middle, but it's
The number in the middle. Where the y values repeat, find the number in the middle. Other questions on that page? Go on to the next if not. And this section is just finding solutions from the graph. Which of these do you want to see, do you go over, have questions about?
199 until 4.
And popular today. Well, 4 has. Okay, so we're looking for, where does this cross the x-axis?
Okay.
This one doesn't, so none. For 204, we're looking for where does this one cross the x-axis?
Oh.
It only crosses it once.
5, 0.
So for these, you can have 2 solutions, 1 solution, or none. Other questions on this page? go on to the next. Quadratic formula is not up here, but it should be. You can write it. X equals negative b plus or minus square root of b squared minus 4ac all over 2. Which of these do we want to see do go over have questions about?
205.
So let's start with 205. Label your A, B, and C. Whatever is before the term that's squared, that's A. If you have a term in the middle, that would be B. In this case, we don't have one. So we have A, we have C. So B in this case would be 0. And then knowing those three numbers, we're going to put it into the equation. X equals negative 0 plus or minus square root of 0 squared minus 4, that number is always there, times A, which is 1, times C, negative 36, all over 2 times A, which is 1. Once you have all your numbers in there, you're just simplifying. So this would just, we don't even really need this part, the 0. Keep the plus or minus. The 0 wouldn't change anything, but I can put this part in a calculator. Negative 4 times 1 times negative 36. Then you would look and see, is the number underneath the radical or underneath the square root a perfect square? This one is. And you would simplify it. Then you would separate it, do the negative and then the positive version. And then simplify it one last time and write that as a solution set. In this case, you could have just done plus minus 6, either one of them. Questions on that one? Let's do 209. Same process. Label your A, B, and C. And then start to put everything in your formula. X equals negative B. 3 is positive, so it'll just be negative 3 plus or minus square root of B squared minus 4 times A, which is negative 6, times C, which is 15. All over 2 times A, negative 6. And then start to simplify. So X equals negative 3 plus or minus square root of 9. And I'm going to multiply those together. So 360. Then I can add what's underneath the radical of the square root together. see if 369 is a perfect square. It is not. So in this case, you're still going to split it. But you would just write it as -3 minus the square root of 369 over -12, and -3 plus the square root of 369 all over 12, -12. And that would be it. You wouldn't need to keep simplifying. Other questions on this page? Once you have that down, go off to the next. And then 8.1, domain range notation. Which of those do you want to see do go over more questions about?
How about 213, 214, 215? 219, and how about 222?
So 213, 214, we're trying to find the domain and range. Put a side note up here. Domain, you're looking left to right. X values. So for 213, furthest left to furthest right, this is going to, because of the arrows, it's going to keep going off the graph, down and slightly left, and down and slightly right. So it's going to keep going in both directions. I'm going to write this in both types of notation. Interval notation would be -infinity to infinity. Set builder notation would be the weird E and the weird R. All row numbers. The range, we're looking lowest to highest.
This would be negative infinity.
Yes, it's where it starts when you write this. So in interval notation, it would start at -infinity and it would stop at +2. It's included, so that would be a square bracket. In set builder notation, that would be everything below, sorry, not x, y, below 2. So y is less than or equal to 2. So then what would the domain of 214 be?
Three to positive infinity.
Your domain, not your range.
Oh,
Your range is that all the time.
negative infinity to positive infinity.
Yes. So I'm just going to write it in interval notation. If you want to write it as set builder, you can also do that. So look out for arrows or endpoints. 215, increasing, we're looking for, as you're looking left to right, where your y values are going up. But you write x values. So as I'm looking left to right, I see that this keeps going. But as I'm looking left to right, if I keep going to the left, my y values start to go down here. They start to go back up here.
to 0, 4.
It would be 0, but then x values to 2. Yes. Decreasing would be the opposite. You're looking for where your y values are going down as you're looking left to right. So starting at negative infinity for your x's, your y values start to go down and stops at 0. So that would be negative infinity to 0. Mm-hmm.
For the 0, where is
Starts at this point, ends at this point. Constant, where your y values don't move as you look left to right, starts at 2 and ends at 7. But 7 is open. So this next section, you're trying to write these in interval notation, so it should look something like the ones down here. For 219, it's in between two numbers, so it's going to look very similar to one of these. The 1 has the equal to, the 10 does not, so the 1 will be in brackets, the 10 will be in parentheses. And then for 222, when we made this, it didn't like the infinity symbol for whatever reason, so we wrote out infinity. But you're trying to make this look like one of these. If it starts at -4 and it keeps going to infinity, it's going to be everything above -4 or greater than. It's a bracket, so greater than or equal to. You can use x or y, doesn't matter. Go on to the next page. We did. You can. One more. It's going to look the same as this, except. And then the next page will be the last that we do. We got through a good majority of this. The rest is on Canvas. And once we go through this page, you can come see me with other questions. If you're staying after, you can ask me questions, things like that.
Wait, how many questions?
One of each objective.
It won't be like this thing, though, right?
No.
Oh.
One of each objective. Find any questions you want to go over from this page?
227. How about 230 as well? Oh no, it says 227 and 230. Yeah, 230.
Okay. So for these, you have to remember all the words, what they mean, where they go. So I'm going to write this at the top. These are your two equations that it'll be written in this format. Either y equals a times, in parentheses, x times h, outside of the parentheses, squared plus k. Or the same thing, but instead of the parentheses, absolute value letters. Not squared. So we're going to be using one of those for each of these. So for 227, we have to look at the words figure out what type they are, where they go. Anything that's vertical goes on the outside, anything horizontal goes on the inside. They tell us what type of function it is, so we'll use that first one, not the second one. This is vertically compressed by a scale of 1/3, so this goes on the outside. That is going to be your A value. Then it tells us it's translated down 2 units. Down is vertical, so that's also going to be outside. That's going to be your K value. And then reflected across the y-axis, if this is the y-axis, is doing this. So that's horizontal. So that's going to be inside. But when we put that in our equation, it'll be in front of x. So then we can start to piece all those things together. You can use y equals or f of x, it doesn't matter, they're the same. We have an a value, so that's going to go first, so 1/3. We need parentheses. We don't have an h value, we have a horizontal value, but not an h value. But we do know that the reflect needs to go in front of x. So the reflection is going to be a negative in front of your x, with the square on the outside. And then down 2 units would be a negative. Questions on that? For 229, the parent function has switched. It's now absolute value of x. This is stretched vertically by a scale of 5, so we know it's going to be outside, and that's going to be your a value. Reflected across the y-axis, again, that's horizontal. So it's going to be inside, but it's going to be in front of x. And then translated 2 units down. These are basically the same. So this is also going to be on the outside, and that's your K. So y equals or f of x equals your a value, 5. Now we're using the second equation because it's absolute value. You don't have an actual h, but you need to make a negative in front. And then your k value is down 2, so negative. Questions on that one? And then at 230, we have our parent function. Translated 12 units to the left. That's horizontal. That's going to be your h value. And 18 units up. That's vertical, so that's outside. That's your k. So we have f of x or y equals. We don't have an a, so 1 or nothing. Whatever you think this is, it is moving to the left, so you probably think it's going to be negative, but when you put the negative in here, it becomes positive. So it's always opposite. So x plus 12, and then 18 up plus 8.
Do you have other questions?
So if you want other questions asked or answered, you can come up to me individually. I'm from up here. I've been talking all day.
Yeah.
If you are staying after, make sure you make an appointment. Remember, today's the last day to do so. We are going to draw names today. I have to get that ready, so give me a second.
I'm not ready for this final, Miss Thorpe, but I'll try.
All I can really ask for.